Hi everyone, I'm Kevin Wagner from the University of Arizona, and I'm excited to share with you these images of young and forming planetary systems. Theoretical models of planet formation have long predicted that planets should drive observable structures, such as gaps and spiral arms, that images have now revealed in nearly every disk that's been observed. The four systems shown here are among this group. Each shows at least one observable structure that can be attributed to the presence of a companion, in some cases even a companion that we've been able to image. The first system, HD 10453, is a benchmark system for companion-driven spiral arms. While the companion in this case is a low-mass star, the same models that are able to reproduce the structure of this disk also predict that similar spiral arms can be driven by giant planets. This provides motivation to search for these spiral arm-driving planets around the other young stars with spiral disks, which we'll return to shortly. The second system, PDS-70, is another benchmark system for companion-driven gap opening. PDS-70 hosts two super-Jupiter planets interior to its 60 AU gap. The interior planet, PDS-70b, is seen here in the accretion tracing H-alpha filter. The discovery of H-alpha emission from PDS-70b also opens new possibilities for studies of planetary accretion. The third system, MWC758, is one of the spiral disks that I mentioned previously. Like HD 10453, the spiral arms in this disk are likely driven by a massive companion. However, in this case, the lack of a low-mass stellar companion implies that the spiral arms are instead driven by a giant planet. We imaged MWC758 in the thermal infrared with the Large Binocular Telescope and discovered a candidate giant planet with many of the anticipated properties of the planet responsible for the spiral arms. While we aren't confident yet that the object labeled CC1, or Companion Candidate 1, in this image is actually a giant planet, our team is continuing to follow up these observations in order to answer this question. The fourth and final system is PDS-201. This is a disk that our team recently imaged for the first time, revealing a disk that is much larger than we expected, which hosts a gap that is also surprisingly large. Compared to the gap in PDS-70, the gap in PDS-201 would require a planetary system that is more than twice as massive and more than twice as extended. Similar to MWC758, our team is continuing to follow up PDS-201 in order to search for the planets that we think are likely responsible for clearing its wide gap. Finally, the ensemble of these systems, and the other examples of young disks being imaged by ALMA, SPHERE, GPI, etc., show that planet formation is a common, if not ubiquitous, process, and that there's much to be learned about planet formation and planet disk interactions by imaging and studying protoplanetary disk substructures.